Good afternoon, everyone. Thank you very much for joining us today for our MiDOG webinar. This is actually the third webinar that we are hosting this year as part of our CE series. Let me please briefly introduce myself. My name is Dr. Janina Krumbeck. I'm the Director of MiDOG Animal Diagnostics. MiDOG is an independent testing laboratory within a CLIA certified facility in Tustin, California. And what distinguishes MiDOG is that we employ state-of-the-art molecular-based next-generation DNA sequencing as a diagnostic tool across various sample types and all types of animal species, including bees. With our all-in-one test, MiDOG excels at delivering advanced diagnosis for infectious diseases in all animals, offering a swifter alternative to culture sensitivity and a more comprehensive approach than PCR. For today's event, we have two co-sponsors. The first one being the Southern California Veterinary Medical Association, the SCVMA. The SCVMA is also the one providing the CE credit for this lecture, which you will receive at the end of this presentation. There will be a link in the chat where you can download the CE, or you can simply email us, or there's also going to be a link where you can download it directly. Our third sponsor today is Dr. Felker from the Exotic Vet Support, who will introduce himself in just a second here. So we will have plenty of time at the end for all of your questions. So should you have any questions during Dr. Mayer's presentation, please simply put them to the chat and we will go over all of them at the end of the presentation. Dr. Felker, would you mind introducing yourself?
Thank you very much, and thank you everyone for joining us today. So yes, I run a online teaching platform, Exotic Vet Support, and what we do cover vet-to-vet telemedicine support. So if any vets have difficulties with a certain specific exotic animal case, you can always contact me, and then I can go through which diagnostics should run, or if you've already run some, we can go through those together, what sort of treatment plans we need to go forward with, and I can help sort of coach you through that specific case, and we can cover cases in the future as well. We also have an online webinar library or teaching video library that covers specific diseases, and then I do some case studies, how to do certain procedures like place an O-tube in a terrapin, for instance. And then more recently we started doing some live webinars, and all of these offer CPD or continuing education certificates. And then in the future, or actually starting from January, we're going to start introducing exotic nurse support as well. So not just for vets, we can get some nurses involved as well. So hopefully that can help lots of you out there as well. And then also we've just started running an annual exotic animal conference as well, so the Asia Pacific conference. We did the first one at the beginning of this year, very, very successful, so we're going to go ahead and do another one starting next March, and we have 5 speakers this year, 3 of which are specialists, so very, very excited to be running this. It will be in Melbourne, and tickets will be released on the 9th of September. So if you'd like to sign up to that, obviously contact me, or you can see it on my page, exoticvetsuppport.com/en/event. All right, so I hope to see lots of you there. Any questions, let me know. And I hope you enjoyed this webinar today.
Thank you, Dr. Felker. And with that, it's a pleasure for me to introduce our speaker today, Dr. Jörg Mayer. Dr. Mayer grew up in Germany, where he received his primary education. He went to Budapest in Hungary to study veterinary medicine shortly after the Iron Curtain fell. During his studies, he was fortunate to be able to work with veterinarians in South Africa and Namibia for 6 months. He always had a strong interest in exotic animal medicine. After he received his doctoral degree from the University of Budapest, he went to the USA for an internship in zoological medicine and surgery at the Roger Williams Park Zoo in Provence. At the end of his internship, he was part of a research team to study tree kangaroos in the rainforest of Papua New Guinea for 3 months. I bet that was pretty awesome. After this exciting experience, he went to the Royal Veterinary College in London, in England, to study for his Master of Science degree in wild animal health. The master's project focused on lead toxicity in the common loon and brought him to the Tufts Wildlife Clinic in the USA afterwards. There he was hired to serve as a clinical associate professor and as the head of clinical services for exotic animals. He's currently a full professor at the zoological medicine at the University of Georgia. Dr. Mayer lectures regularly at large national and international conferences on all aspects of exotic animal medicine, including honeybee medicine. Dr. Mayer qualified for the first batch of specialties in exotic companion mammals as a diplomat of the American Board of Veterinary Practitioners. In addition, he is also a diplomat of the American and European College of Zoological Medicine. He served as the president of the Association of the Exotic Mammal Veterinarians from 2010 to 2012. And since 2012, he's also the International Fulbright Specialist in Zoological Medicine. As you can see, Dr. Mayer has many accomplishments, and he has published many scientific articles, book chapters, of some of which have been translated to French, English, Spanish, and Portuguese. His latest book, The Veterinary Clinical Advisor for Book and Exotic Pets, was published in early 2013. Also in 2013 and 2024, he received the Exotic Speaker of the Year Award by the NAVC. And in 2018, he was voted Continuing Educator of the Year in Exotics at the Western Veterinary Conference. In 2016, he received the Oxbow OEM Exotic Animal Health Award and an annual award to recognize the excellence and innovation in the field of exotic mammal health. And with that, Dr. Mayer, please go ahead with your presentation.
Okay, thank you. Wow, I didn't know you're going to read the whole thing, so I'm pretty sure we lost half of the audience already. So if you're still there, thanks. I'm really excited that so many people showed up for a topic that I personally find super interesting, but I'm always floored that other people are interested in that too. So without much ado, let's get going. All right. First of all, I want to thank the Georgia Beekeeper Association because they were extremely instrumental in making this all work, because I was supported by them with a fund. And that is still ongoing. So project is still ongoing. So they have been amazing and really pushing the envelope in a little bit what we know about bees. So I'm extremely grateful to this organization. Why do we even talk about bees? Why do we talk about bacterial diseases in bees and stuff? As some of you, I hope the vast majority of you actually know that we have basically a global crisis at our hand. The invertebrates in general facing a large extinction event, and obviously we have a lot of data on the honeybee, and you see here a census from actually last year where I think nationwide beekeepers lost about close to half of their colonies, and I think in Georgia we are right there. I think Georgia specifically was kind of like 46%. So as you can imagine, if that would be the case with any livestock other than bees, there would be a serious alarm bells ringing in state capitals, and funding from the agriculture sector would probably flow in to investigate this. And yet with bees, it's still a little bit under the radar. But as you probably also know, that probably a third of everything we eat it somehow depends on pollination services by the bee. So without spending too much time on this, I just want to make sure that everybody understands the significant threat that micro-livestock honeybee currently experiences. So I was told that probably the audience is probably a little bit mixed. There's probably some veterinarians in there that maybe could give that talk, that are really good, well experienced with honeybee medicine. There's maybe some veterinarians in there that are just interested, but maybe don't know that much, but are intrigued. And maybe there's some non-veterinarians in there. So whenever we have a broad audience, it's a little bit of a challenge to basically cover all the bases. So if I skip something, because the limit of time, but I'm going to try to introduce the main topics here and still be hopefully able to finish in time here. So bacterial diseases, why do we talk about bacterial diseases? Well, the next couple of slides hopefully explain that a little bit. The two big ones that we really need to know, especially as a veterinarian, if we're interested in potentially in the future helping beekeepers to fight those two, it's the American and the European foul brood. So basically, what are the problems with them? So as the name already suggests, both of these pathogens actually kill the brood or affect the brood. Then they become kind of like rancid in the hive, and the hive starts to smell poorly. Like some people kind of phrase it like old tennis socks or bad cheese or something like this. So it definitely has not an aromatic smell in the colony anymore. And obviously it is a huge potential to decimate colonies. So both American foul brood and European foul brood are episodic. So the name American and the name European foul brood just basically refer to where the disease was first described, but they'll be found all over the world. One of the main differences between them is that American foul brood, at least in the United States, and I think in Canada too, is a notifiable disease. So therefore, if you're a veterinarian, you should, and you want to help beekeepers, you should be able to differentiate American and European foul brood. Both of these diseases are potentially treatable with antibiotics, and so however, there is obviously legally there's a big problem. One of them, the American foul brood, is notifiable, versus the European foul brood is not notifiable. The interesting thing is that they kind of, to the untrained eye, they do look very similar. And so this is why I just quickly want to spend 1 or 2 slides on maybe how to differentiate between them. So, and a big problem with American foul brood. So American foul brood is actually a spore former. And those spores have been shown to be persistent on the equipment, in the environment for decades. So it's actually very, very difficult, if not impossible, to eradicate American foul brood from a hive once a clinical outbreak occurred. So, and in contrast to European foul brood, which a lot of times can act an opportunistic invader, American foul brood is a primary pathogen. So you don't really need any other stressors like lack of nectar flow, not the ideal microclimate. So American foul brood can take down a hive very quickly and all on its own. And it's obviously highly infectious. Only a few spores are really needed to decimate a colony. So if that sounds a little bit horrible, it actually is. So this is why I like to refer to that disease as the anthrax of the honeybee. And studies have shown that just minimal effective dose, just like 10 spores, could be enough to decimate a completely healthy colony. So that's pretty scary in itself. And so what do we do in the field? How do we potentially should be able to tell if it's American or European foul brood? So for the American foul brood, the upper left pictures, the 2 pictures are commonly used. So you have that one, the matchstick, the ropey test, where you take a little matchstick or a blade of grass, you go into the cell where the dead larva is, and as you see, because the disease literally melts down the larva, you have this chewing gum, stringy kind of like consistency. This is pretty pathognomic for American foul brood. Or in that black and white drawing, you actually see, if you look into the cell and you see this one little peak there in there, that's usually the tongue of the developing pupa, because that's already a little bit keratinized, it doesn't melt. So that's the only thing that sticks up. So these are kind of like rough ideas that you may be dealing with it. There is also kind of like, there used to be, past tense, there used to be, to my knowledge, that little lateral flow device test is not available anymore. If you can still find it on Amazon, buy it. It's kind of like one of those little snap tests. And but unfortunately, I think, at least in the US, they're not commercially available, and that would give you like a positive sign. Other than that, you would have to potentially then send your samples to the lab. And as you see here, there's quite a few different methods where you can potentially confirm the suspect diagnosis. And as you see, most of them are fairly reliable. However, they're fairly specific, as you see with the PCR. So you need to potentially, find a lab that runs them and then express your concern that this is American foul brood, that they really look for it. So moving on to European foul brood. So again, it's a relative, and European foul brood can affect a lot of different honeybees, not just like the western honeybee, Apis mellifera, but also the eastern, Apis cerana, and the giant bee. So it's kind of like the way I describe usually European foul brood. It's a little bit like a really bad traveler's diarrhea. So the little babies get infected by the nurse bees, and then basically it causes a really, really bad diarrhea. And it really is bad, and you have potentially secondary invaders come in and finish the job off. So it's very common that you actually see a mixed population in the intestines, but there's also some evidence out there that actually in severely affected colonies, those bacteria actually leave the GI tract and cause a systemic problem, so to say. So a recent paper was published out of Michigan State, and so again, what they looked at is like, what do we have in the field, what can we use to kind of diagnose European foul brood? So as they already see here, it's difficult to diagnose through visual inspection alone. And again, every time when you have two diseases that look relatively similar and one of them is notifiable and the other one isn't, you want to make sure that you hit it right. So in that study, they used that lateral flow device. They compared it to the microscopic examination, which obviously means that you should be a little bit experienced what European foul brood and American foul brood looks like from a microscopic exam. So again, it's probably you have to be a little bit of a microbiologist, or you have to have quite a few sessions behind the scope, and then you have a PCR, which again is obviously a very specific test. Their conclusion was that all three methods are highly sensitive for European foul brood. And so, however, one thing that was interesting to me is that they had a lot of false negatives on that lateral flow device, on that little snap test. And so initially you would think maybe with a false negative, is it potentially the low number of antigen that is presented? So if you just have a background contamination, could that be the problem? But also they noticed that they have, and those false negatives, they have high loads that they actually determined with the PCR. So it seems like there's already different strains out there that lateral flow device didn't diagnose probably. So that was kind of interesting in my point. So the differences, yeah, so as I already said, don't want to spend too much about it. It's like we know that it's extremely resistant. American foul brood is really bad. You don't want to see it. I personally have not seen it with my own eyes, and I'm really happy about it. I'm happy to copy those pictures from books, but you don't really want to be in the middle of that. The problem is that European foul brood, as I said, looks similar, and that can be actually treated in a conservative way. And I always use my European colleagues and beekeeper colleagues, because in Europe, it's not even allowed for the veterinarian to prescribe antibiotic for the beehive, because if they think it's European foul brood, you just have to tell the beekeeper potentially, well, we got to work on husbandry together here, and you got to figure out what it is, because legally I can't even use it. Here in the States and in Canada, we can use antibiotics. And so a lot of times antibiotics is thrown right into that, colony gets better, hopefully, and everybody celebrates. Here's the problem, though. So as you now appreciate, they're not the same, they're fairly different. However, both of them would actually respond a lot of times favorable to tetracyclines. So this is one issue already if you don't know exactly what you're dealing with, because you're like, oh yeah, this one, well, it was most likely European foul brood. Well, one of the things is if it was American foul brood, then your case is not over, your case is not solved, because that colony needs to be persistently exposed to antibiotics, or all of the equipment needs to be destroyed. So basically, the issue with throwing tetracyclines at it and get better without really knowing what it is, it's a pitfall. And the analogy that I want to use is kind of like this: if you deal with a whole bunch of sick birds from a breeder or something like this, or an importer, and a lot of them are dead, and they respond to tetracyclines, so oxytetracycline, you wouldn't be assuming it's chlamydia, right? You're going to be like, oh yeah. So, but that's kind of like the status from a bee medicine point of view, what we're practicing right now. Most of the time, we're really lacking in good diagnostics, and so hopefully this will change in the future. All right, so here's a prime example, a real-world example. This is a standard case. Colony a lot of times is reported as a poor doer. In the spring, the nectar flow is happening. The colony should build up. It's not happening. Beekeeper examines it, notices a poor brood pattern. So again, if you are here and you're not 100% sure what a normal brood pattern looks like, I'm going to just show you a little video. So this is kind of like what normal bee brood should look like. I want you to recognize that you have this nice little pearly like a color or a sheen to those. You see those larvae sit a little bit in royal jelly. This is their nutrition. And again, this is what the nurse bees regurge in there and then potentially also regurge the infectious material. But those look really moist, juicy. They look plump. They look healthy. So that's really nice. But you would also see a general pattern there. Versus now, let's take a quick look at more or less a kind of like diseased brood, and hopefully you appreciate a difference. And sometimes it is subtle, but in order to be a good veterinarian, you need to catch this all up. Here you already see they look a little bit dried out, right? So you see kind of like a little bit that skeleton in there. This one is breathing, actually. You see a little bit. But as you kind of hopefully you can agree with me, it doesn't have that nice pearly white sheen to it. It actually looks already a little bit yellow, and that is very common. And again, that size of the larva is actually, that's also typical. So these are probably 6-7 days old. They usually get infected when they're 3 days old, something like this, and then it just takes 3-4 days of that really nasty diarrhea to really finish them off, and then they sit there dead. So hopefully you kind of appreciate this, but again, this is one of those examples where you just need to spend some time. Oh, there's a nice one. That's a nice shriveled one up. There's nothing moving, and it's actually already a little bit like mummified here. So that's a bad one. So this is you know, not good. So, all right, so hopefully you have a little feel for it. So here you see just basically that frame in toto, and you see there is what would be considered a very poor brood pattern. So very few capped cells here and there. That should be full of capped cells. And so here you see also a pattern, that black in the center, that tells you that, you know, the previous brood pattern was right there, and then around that there's usually nectar and pollen to feed those, but you see there's a lot of them missing. And this is where you hear this word shotgun brood pattern, because it kind of looks like somebody took a shotgun to it or did something nasty to it, like our little friend here. So highly abnormal. So and the problem is, again, think of the birds affected with chlamydia or anything else. It will kill usually the baby birds, right? Nestling killers, kind of thing. So the brood is kind of like the tip of the iceberg. Those are the immune compromised, you know, parts of the hive. Here you see again where they shriveled up, where they, hopefully you can appreciate that they look a little bit yellow, and they kind of have a little bit that skeleton-like character to it, where you see actually also the spiracle system, but this is not a good hive. So this one you definitely want to sample. This one we sampled using that lateral flow device, and sure enough, we've got 2 positive. The test is positive and the control is positive. So this test was working, and unfortunately, it's bad. So, however, what that just tells you, it's a binary answer. It's like yes or no, right? It's not going to tell me. It's like, wow, is this lost, or is that just kind of like starting to creep up on us? So there's a little bit. It's a first problem with that test, but I know it's better than nothing, right? And then, so I actually cut some of that honeycomb out here that you see in the middle is missing, and I sent this to the lab, to a very good infectious disease lab, and this is the answer that I got back. And it's like, unfortunately, this organism requires specialized medium, and we don't carry this, so we're unable to culture this. So again, if you are thinking about doing this, make sure that your lab knows ahead of time what you're looking for. Be as specific as possible. Say that, hey, I'm suspicious for Melissiococcus, and maybe they'll save you the postage because they say, oh, don't send it to us, we can't do anything with that, right? So if you look a little bit in the literature, it's actually really interesting if you're a researcher and you're doing research with European foul brood. You know, it's a fastidious organ with microaerophilic or anaerobic conditions, so it needs actually potassium phosphate. So that's why it potentially doesn't grow, because you need special medium. So it's actually a fairly tricky little bugger to keep alive in a lab. So here's also a picture from that where they actually looked at all these different mediums, and you see how the pluses here showing successful culturing only happens in the more or less microaerobic or anaerobic environment. So again, if you would have a lab that does it, probably use your anaerobic swab to it, and that might help you. However, just want to point that out, how tricky it is, even for people that know what they're doing and looking for it. So there's a real challenge for you right there. So again, here's an example where we used next generation sequencing in the field. So basically, this was kind of like a study, again, funded by the Georgia Beekeeper Association, where kind of like, you know, a microbiome study. It's just like, hey, what's going on? Even if the hive looks okay, what is actually going on in that brood nest? So for this, we just sampled 2 to 4 larvae, kind of like in a destructive way. As you see right now, this is the swab, and it fits perfectly right into one of those brood cells and another one. And so yes, destructive. So we're squishing that larva, but we want to really see what that microbial load is, because it's a brood nest. There shouldn't be too much really, or it should be healthy GI tract. And then we put it in the medium and send it out. So here's that example. This is a hive that was kind of like doing okay, hive 11, and that was in May, 10th of May. And you see, yes, we get 16,000 cells per sample back. So overall, 9.6%. And as you maybe, and I think we'll see that movie again in a second, you'll see that actually, if you pay attention to the brood pattern, that was actually a little bit surprising. I'm like, oh, wow, that is European foul brood in the hive, because clinically it kind of looked okay. And as I said, 9.6% only, so it definitely wasn't the majority. It's like 90% was Bombella intestini, which is a beneficial, which is probably, maybe you want to compare it to E. caniculi in our, E. coli in our gut, or mammal gut. So it's like, okay, it's there, you'll find it, but that Melissiococcus is kind of like, let's keep an eye on that, right? And I was kind of intrigued. We'll definitely resample. This might also be one of those cases that if you have access to those lateral photos where you make it a false negative back. I really don't know what the threshold is from an infectious point of view, how much antigen needs to be before they become positive. But that could also be that you would get a false negative on that row back, because obviously you need a certain load of antigen to get positive. And I don't know what that is, but 16,000, that's not that high. But you know, it was kind of like, let's keep that. So again, you see actually here that video again. And so what I want to do is like, hey, let's go back in 4 weeks and see what's going on. So we sampled again, and we marked actually the frame where we took the sample. So I want to be as close to the original. So I mean, this is the same movie, but and look at the brood pattern here. That's actually considered fairly good. That's not something that I would consider a shotgun brood. So there's always a few open in there. So, and the colony looked strong. Okay, so we collected that again, and we send it out. And you know, put it in the overnight express delivery for FedEx, and I was really excited to see the results 4 weeks later. And this happened. I think it was very much express. I think the driver took that a little bit too serious. So, and the sample just got lost. It never showed up anywhere, despite a tracking number. I was really sad about this. And so I don't want to throw FedEx under the bus here, literally, because it seems like UPS also offers express delivery. So kind of surprised how frequently those stuff burns down. So anyway, maybe you in the future you want to bank a couple samples, you know, because it can happen. So unfortunately, sample was lost, so we didn't have that. So again, a month later, we go back in. 310 million. Yeah, because clinically it looks a little bit worse now. But now, from whatever 9%, now it's 60%. That's a problem. Right? That's a problem. it definitely is #1 now, as you can see, and it outcompeted everybody else in there. So at that point, I decided, well, it's like, I'm a veterinarian, I want to be responsible too. And part of the thing was like, can we treat with probiotics? So one part of the study was like, if we have a case like this, and that study is still ongoing, I'm looking for cases with European foul brood to throw a whole bunch of probiotics out. Can we potentially outcompete this? So I definitely did throw this on there. I sampled it a month later, and now it's September. Now great enough. The colony did really well. And again, I didn't want to use antibiotics. So the sample now is down to 2,800 cells, I would say, consist. And so what we see, the rest of this Galliamella is a normal, intestinal part of the population. Bombella is normal. So all of these are really great. Lactobacillus is actually part of the probiotic mix. It's interesting that some of those that are really high now, they're actually not part of that probiotic powder, but that's part of the normal intestinal flora. And so I think that that this is beneficial part of that probiotic to just basically outcompete the Melissiococcus and let the normal fauna and flora grow in the honeybees. So then I went back even a month later, and which is great because now there was no Melissiococcus in that. This was really good. So again, there's lots of lactobacillus. Yes, because I've been supplementing a lot with the probiotics, probably more than was even needed. But I just want to make sure I want to make a point. So, and that hive did really well. So that was a nice one to have a little bit of a longitudinal way to look at that. So as a quick summary, in that case, I think like Next Generation was really helpful in diagnosing a potential pending problem, basically sensitizing me to that hive and then just following through it, documented obviously the rise of the pathogen. And because I was sensitized to it early on before the problem really got clinically super bad, I think I was able to prevent major damage, hopefully with the probiotics, instead of having to use antibiotics. And then at the end, we could really use it to verify kind of like a clean status of it that, probably don't have to worry about this. So that was pretty cool. Here's the second case that I want to show you guys. So as you see, you now hopefully appreciate a little bit of a shotgun brood pattern here, and you see kind of like these also, I hope you see that they also have a yellowish kind of sheen to it, those dead larvae in there. So not healthy at all. So concerning, seriously concerning. That came back with 4.6 billion, right? So also, this is a huge amount, close to 60%. So this is definitely one of those ones where like, oh, wow, we've definitely missed the early stage here, right? So, and this is where I just want to quickly mention a little bit about treatment, so if you ever have a case like this and you get, you are in a situation where, people want to use antibiotics. So I just want to point that out, right? So again, oxytetracycline is definitely the drug that is approved and you want to start with. And so, and you can go online, it's like if you're worried, if you have never written kind of like a veterinary feed directive or if your prescription for honeybees, don't worry. The Honeybee Veterinary Consortium is really great for you. If you're interested in that, join the Honeybee Veterinary Consortium. They provide you with a pre-printed veterinary feed directive. They make it extremely easy, but there's other resources available too. Also for beekeepers who are on the call who maybe say, oh, I don't know a veterinarian who would be willing to this. They can obviously also go to the Honeybee Veterinary Consortium. You put on your zip code or your state, and hopefully you'll find a few veterinarians that are registered and potentially would come and diagnose that for you. So again, you can get these premixes, obviously used, as you see, for poultry and cattle and swine and all this stuff. And the honeybee, this is legit. This is all okay. I just want to make sure that that everybody understands how little antibiotics we actually need. So apply 200 milligrams of this mixture per colony. So, and again, here's like if you Google if you just put in Google FDA and bluebird label, you come to a really cool, algorithm that helps you kind of like print out all these instructions and everything, because you're dealing with a food-producing animal. So there's some, like I said, there's some legal requirements that are a little bit different than just writing a script, and that has the potential to imitate some people, especially if you've never written a veterinary feed directive. So, but back to the 200 milligram. This is my finger, and yes, I'm not a finger model here, and this is a gram. So this amount of that mixture is literally enough to treat 5 beehives. So sometimes I see kind of like these scenes where, you know, beekeepers or even veterinarians have access to obviously the antibiotics and throw it in, and they just usually use the hive tool and just fling a whole bunch in there. Well, if my doctor tells me take one of those pills once or twice a day, I'm not going to take a whole pack, because I think more antibiotics is not going to make me faster, better. But for some reason, you know, we have sometimes maybe a hard time appreciating what 200 milligrams is, because it is small. So this is enough to treat 5 hives. So what you want to do, you would want to divide this in 5 if your scale doesn't go below 1 gram. And then you want to just mix it with powdered sugar like this. And this is what it would look like. You just mix it a little bit with powdered sugar. If you zoom in, you can maybe appreciate it. This has a little bit of a yellow tan to it, and that's enough. And gee, it lands on the bees, they groom it off, and then the nurse bees are hopefully clean, and then they can feed the babies and everything will be fine. And that needs to be repeated every 2 weeks, I think, for 3 times. So just a few words about the treatment. So again, with this severely infected case, so obviously in that case, NGS was really helpful with diagnosing this is a real urgent problem. So this is like, wow, you have a significant outbreak here. So you could actually talk to the beekeeper. It's like, hey, listen, whatever, a couple billion, you know, spores there or cells there. So do you want to actually potentially invest any kind of energy and resources in that? Or do you want to just condemn that hive and definitely remove it from the apiary? Or on the other side, you could be like, well, we can try, but, you know, I think the prognosis is very poor, because we all know if you potentially script it out, you give antibiotics, and it doesn't work, the hive still dies potentially. That, you know, could maybe shed a bad light. It's like, yeah, I went to Mayer, I paid money, he gave me this, the bee still died, and as we say in the South, bless his heart, you know, and you potentially lost a client. Versus like, it's like, oh, wow, this is really bad news. I'm really worried this is actually not salvageable anymore. So, and in addition, it kind of like gives you a much better way of saying, yeah, you have it, or no, it's clean. So this is definitely one way of quantifying the severity of the infection. So very helpful, I find. All right, here's hive number 3, ready. So again, as you kind of see, they all kind of look the same. And I swear to God, these are pictures from these. It's not just like one hive that I keep showing you over and over. So this one is a little bit interesting. You already see that some of these cells, I don't know if you can see my my mouse cursor here, but as you see, there's some of the cells have been chewed up by the bees. And so this is what's referred to as hygienic behavior. So the bees actually walking over those cells, and for some reason, they can probably smell it or something like this. They notice that the developing larvae underneath, or the pupa underneath, is not doing well, it's diseased. So what they do, they just chew a hole into it to potentially look into it. And if everything would be fine, they would just, you know, produce a little bit of wax and close it up again. But what they are noticing is like, wow, there's a dead baby bee behind it, and we potentially need to remove it and make room for more, right? And so as you can imagine, there's something has been festering in there. During that process of removing it, obviously they're doing it with their mouth, with their feet. So there is a potential, obviously, for these nurse bees or for those, you know, removal bees to get contaminated and potentially infect others. So as you see, the big larvae there, one of them is yellowish, a little bit melted down, and doesn't look healthy. So of course, you know, the suspicion is like, oh, you have European foul brood, because it is not ropey like that American foul brood causes, right? So, and literally, this is the test that I got back. I'm like, what? This is actually, from a microbiological point of view, it's looking really good. So all they could come up with is that Bombella intestini and the lactobacillus, and I was like, this is good stuff. Why is my hive looking like this? So, you know, scratch your head a little bit. But again, if you then in hindsight, if you think about it, it's like, yeah, they did open that. And usually when it's pure European foul brood, like I said, they die when they're like 6, 7, 8 days old, definitely before they get capped, and the bees remove this. So chewing these covers open probably indicates that those ones die at a later stage, right? They're being capped on day 9, and then they die maybe on day 11, 12. Then they start to stink a little bit, and then they start looking into it. So there's probably something else going on. So, and it was severe, as you saw from that picture. So that triggered me to collect more data. So now I wanted to know more, and I thought, what's the next step? The next step is you know, having microscopy done on it. So basically fish that out and try to be as gentle as possible, not to damage the little larvae, and then put it in formalin or ethanol or something like this, and send it out for histopathology and see if there's any telltale other sign. Because again, we probably know that bacterially wise we are good. There's no other bacterial infection causing the problem, but maybe we'll find something else. So send it out to the pathologist. They made a couple of comments. Maybe the cuticle, the outer, you know, basically the epidermis. So intestinally did not look bad, but maybe the outer shell looks a little bit vacuous. So in hindsight, if you take digital pictures, which I always recommend, you can go through. I scanned through them and I found this picture. I'm like, you know what? It kind of looks a little bit like sac brood virus to me. It's like slipper. So it's this flat kind of thing. So I said, please run a PCR for sac brood over that. And boom, we had a bingo here at the bottom. Yeah. So it's definitely, it was full of sac brood virus. So again, which is unfortunate, because as you can imagine, for a viral disease, there's not much we can do about it. But again, it's also one of those cases where I didn't want to throw antibiotics in it. So obviously a virus you treat with supportive mechanisms, and you know, but you can get ready to potentially lose that hive. So again, next generation sequencer was really helpful here, ruling out EFB, because, you know, like again, throwing willy-nilly antibiotics on it is not going to be helpful here. It's actually would be considered irresponsible. And so it really triggered me to keep looking for it. Yeah, the real problem was a viral disease here. But again, you get the idea of it, that yes, if a hive is sick, it's usually the brood that gets it, right? Because of their non-existing immune system. Here's another case, and again, overall that picture has a little bit of a yellow tint to it, but I didn't put a filter on or whatever. But you see the brood also, hopefully it's not best in focus, but you see the brood is all kind of a little bit older, and it's yellowish. It doesn't have definitely something what you would say pearly sheen to it. So, and to me I was kind of like, yeah, that looks very suspect for European foul brood. But before we do something, let's take a sample. Oof, this is what it came back as, Enterococcus faecalis. And yes, 11% was Melissiococcus with 150 million cells. But this is potentially like one of those cases where maybe, just maybe, that Melissiococcus, like in that first case that I presented, was maybe around a little bit, and Melissiococcus is around. And so, but if the bees are doing well, their immune system can fight it off and keep it in checkmate position. But something else happened here, and it's definitely the Enterococcus. So that is an interesting one. And I recently just talked to another industrial beekeeper, and they said, hey, we just diagnosed Enterococcus in our, and I was like, oh wow, this is really interesting. Now this is odd because I haven't heard of Enterococcus problems. But again, I think people are starting to look a little bit deeper into it, spending a little bit money on diagnostics and getting hopefully rewarded for looking into this and putting the finger on it. And so interesting. So if you also look at the antibiotic resistance profile for this Enterococcus, there's a lot of red, which is potentially not recommended. We used all these different antibiotics, and you see here tetracyclines definitely not recommended. So most of the times this is because we have genetic resistance already. Here's an interesting paper that I came across that looks actually at Enterococcus faecalis and highly pathogenic. And guess where it comes from? Yes, it's the varroa mite. So Enterococcus is most abundant bacteria in varroa mites. that was a little bit new to me too, until I had that disease and I started to look at this. We obviously hate Varroa for multiple reasons, but one of the reasons that you always hear that why we all hate Varroa is for the transmission of viral diseases, right? Deformed wing virus, paralytic virus, you name it, right? I haven't really found anybody who's like, you know what? You know the reason why I'm hating Varroa? I'm hating Varroa because of Varroa poop. Never heard anyone say this, but now I do. And so this is one of those things where, well, wow, holy smokes, you know. So the other interesting thing that I thought, that this Enterococcus faecalis is only pathogenic to mellifera, but not to Epicerana. Most likely because Varroa co-evolved with Epicerana. So Epicerana's immune system is probably already a little bit immune primed against Enterococcus and can deal with it. So again, very interesting insight in this. Would that potentially have gotten better with throwing tetracyclines in as well? Maybe, right? Maybe. But I think you would have potentially missed the real reason why this really happened. So again, next generation sequencing here was kind of helpful in diagnosing. Yes, there's EFB in there, but you have something else going on. So again, there's something else. And so speculation wise, you know, you could actually say, well, maybe, you know, there was a previous Varroa that was treated with Varroa-cide medication, but as we know, they all like to poop into those cells. The Varroa-cidal drug obviously is not removing the poop, and then it just festers, and it's a beautiful environment to grow in there, and then it grows and kills the brood that way. So again, or maybe it was actually an infested hive, and then they absconded or they died, and then contaminated frames were used from that hive and brought down potentially healthy killers. So, and you're welcome. Now you have another reason to hate Varroa, like we need this, like a hole in our head. A couple of interesting stuff that I just want to throw in there. So this was kind of like an interesting one. So we got this one back. So this one came back with Staphylococcus epidermidis. So again, the hive looked pretty good. You have only 690 samples, so 1%. So I'm like, Staphylococcus epidermidis. So, and the nasty thing was that Staphylococcus was resistant to like everything. So look at this, so much resistance to all these antibiotics. And yes, most likely that one came from the beekeeper, probably working the frames with the normal, you know, ungloved hands, maybe picking the nose in between inspection or whatever, or scratching the arm. And then, you know, so this is what crawls on us. And as I always say as a veterinarian, it's like, yeah, we have our responsibility to protect the animal too. We can bring them pathogens too. So it's actually interesting. It can work in a beehive. And to be honest, I don't know how well they're doing with something like this. So here's another hive that I just sampled, I think 2 or 3 weeks ago. Same thing. Like, look at these larvae. By now you're an expert. You can tell, look, that doesn't look nice. I don't want to have a pearl necklace that looks like this. Bad. So came back, no known bacterial pathogens detected, and even fungal wise, it's like 5-7 cells there. This is not something. So again, there's lots of lactobacillus, so that owner I think is already using potentially probiotics or not yet, but so it's definitely, so again, not a disease that should probably treat it with antibiotics. And yes, I was called because I said, the phone conversation or the email was kind of like, I have European fowl brood, do you want them for your study? I'm like, absolutely, I'll be there. Turns out, no. So I don't know right now what it is. So, but what I told him is like, don't even think about using antibiotics. It's not going to do anything. So, and I don't know what it is. So the problem, as I hopefully was able to demonstrate here in the last 42 minutes, is a collapsing colony always looks similar to everyone, really, right? And so a lot of times what we're doing, we're diagnosing a disease without really doing any diagnostic work in it. And you know, between us, if we're honest, this is not good work. You know, it's like, think of those dead birds. It's like, the birds are dying. It's probably chlamydia. Give them some oxytetracycline. That'll be better. So, and again, we are kind of like, if we start using these diagnostics, I think we're going to be, our infectious disease chapters in honeybee medicine books are going to be probably bigger in the future, in edition 2, 3, and 4, because that next generation sequencing kind of allows us to grow these bacteria that potentially, as I showed, would be fairly difficult to grow in a standardized lab. So like I said, it opens the doors to a couple new problems. I think at the end, we're going to have more questions than answers, but that's exactly what science and research is, right? We want to go in and answer everything, and then at the end of the project, we actually are more confused than when we started it. So, but that's why we love it. And again, I just want to do a quick shout out to think of these little guys as micro livestock, right? You wouldn't go on a farm and they say there's mastitis, and you throw a whole bunch of 50 pounds of whatever antibiotics you use in the cow or feeder. You want to potentially get a sample of the milk. You want to do some investigation, right? Because otherwise, it's a crapshoot what you're doing. And so hopefully in the future, we're going to move bee medicine into next level of evidence-based stuff. So if the other thing that you want to maybe point out is I don't know if most of the people that I talk to at some point in their life, they have been on antibiotics, and we know, yes, we are sick, but when we're on antibiotics, we are not the best, right? And so there's a lot of evidence out there that throwing antibiotics at these bees a lot of times really does set them back. Okay, so it really hits them hard, especially when there's low protein diets, which is a lot of times in the dearth as well. So when they're not doing well, there's obviously sometimes the cause of them not doing well and getting a secondary bacterial infection is because their nutritional plane is not great. So we really know that it really screws them up for a long time after we do this treatment. And so one of the things that I find really interesting is it changes the behavior. So it delays the onset of these pre-programmed behaviors where they start with cleaning, and then, as we all know, their last stage in life is the foraging. So it sets it back for weeks and weeks. So that means you as a beekeeper, actually, if this is your income, you're setting these colonies back significantly, cutting in your honey harvest by the use of antibiotics. So again, there's some papers out there now that have been shown that probiotics are maybe not that useful. I don't know if that's really the answer. In the beginning, I mean, that's a whole talk in itself. I don't want to go too deep. But again, it's really interesting what I've shown with lactobacillus. That lactobacillus for the bee is actually really important for memory function. And so what we know that if we treat them with antibiotics, we're kind of also destroying, just like us, we're destroying this, our intestinal population of beneficial bacteria. And they have been shown that here you see learning and memory. So those bees are shitty foragers at the end. They kind of forget where the good flowers are, even they have been told with a wiggle dance. And it's like, yeah, I told you, why did you fly that way? It's like, sorry, I had a brain fog because I was on antibiotics. So again, there is obviously a lot of reasons why I think we should think twice before we throw antibiotics on a hive, because it has a potential long-term effect on the benefits. So again, think of this. I always use micro livestock as an example. So beekeepers are farmers on a weird basis, right? And so we want to provide the best service, and sometimes just like answering that phone call, doing this and throwing antibiotics in a hive is potentially not the right thing to do, because it potentially is a frustrating exercise for literally everyone, including the bee involved. So in summary, I think I was able to show just a couple examples on how next generation sequencing actually gives us a little bit more insight into the hive, into the microbiome too. And I think we're literally just scratching the surface of this exciting field. So hopefully I was able to convince some of you that this is not kind of like a dog and pony show here, but that was really valuable information from a clinical point of view, which I think makes you a better veterinarian at the end. So I want to thank you guys. This is my kind of idea of investigation to death here. And here is the most important slides for you all. I know you've been waiting. This is your QR code to get your CE credit. And I think with this, the question and answer session is potentially on. Are there any questions? Is there anybody left here? I don't know.
Thank you very much for that, Dr. Mayer. That was a very insightful lecture.
Thank you.
Yes, so if anyone has any questions, please pop them through to the chat. I can see a couple are coming on through. I will actually just ask you one question myself, if that's all right. One question was about antibiotic use. Is there a withdrawal period when you use antibiotics in bees?
Obviously, absolutely. Yes, absolutely. It's just like the, like I said, micro livestock. It's just like, guys. I'm just trying to get into the picture where I can see you. I'm kind of like, I don't know. Let me just. There is a withdrawal period, and I think for oxytetracycline, it's kind of like 42 days or something like this. So again, that's really important. That's also for a commercial beekeeper. It's maybe another good reason why you want to maybe hold your guns a little bit, because literally you can't put the honey supers in there for 42 days after your last application of the antibiotic. So that means maybe a whole season of honey. You're taking that hive out of your moneymaker there. So that's even another reason. Yes.
Oh, good. Thank you very much. Actually, one last question whilst other people are thinking of some questions to put those through. If there's multiple hives at a particular location, how easy is it to transfer disease from one to another?
Oh, great question. Yeah. I think just like that depends obviously how close these hives are. And the studies have been done on natural infection virus, and which is called also drifting, when bees actually accidentally go into a different hive and then they bring the virus up. So having your hive spread out as much as possible is great from an infectious disease point of view. But yeah, one of the things is that you could be the vector too. You could be with your hive tool. So if your hive tool is not clean and you're just popping up all those, all those top boards and whatever, and now you have European, or God forbid, American foul brood spores on your hive tool, and you could bring it over into that new one, and especially if you have hives in multiple apiaries. Now you potentially contaminated a clean apiary. So this is why you want to disinfect, maybe drop your hive tools after an inspection in some disinfectant, or use your blowtorch and just like do heat disinfection. So, but yeah, think of it as a highly infectious disease. The cross-contamination is highly likely. So just use your common sense, use your gloves, throw them out at the end, especially when you leave the property or go to a next apiary. Absolutely.
Perfect. All right, thank you very much. I'll let someone else ask a question now. So, yes, any further questions, obviously just pop them through. Janina, I'm not sure if you had any questions as well.
Yeah, I see some coming through. One actually I can answer. What is the turnaround time for the next-gen sequencing? That would be just 2 to 3 days after the sample is received at the lab. Then another question would be, you talked about both bacterial and fungal infections. Bacterial and viral. Is there any knowledge about fungal infections?
Oh yeah. There's also two main fungus disease, stone brood and chalk brood. So yes, that is also an issue. One of the reasons why, obviously, again, I didn't talk too much about it, because I think the interest from a veterinary point of view to actually learn a little bit about this topic is because you might get contacted by a beekeeper for an antibiotic. So right now we don't really treat with antifungals. But there's two diseases that we should know. If you take any kind of test and a honeybee is part of that, they'll probably also talk about stone brood and chalk brood. So yes.
Mm-hmm. There's a question about Nosema. We didn't quite cover that. Can you expand on that a little bit?
Yeah, Nosema is an intestinal protozoan that has a lot of different research even dedicated to that. So just as an example, when I was in vet school before the war, I learned E. cuniculi, the bunny disease, as Nosema cuniculi, just to give you an idea. And Nosema can cause severe diarrhea in these guys. And so there's a lot of research being done to look at what can we do. Do we need to treat Nosema? Do we need to throw drugs at that. A lot of evidence that I see is like, take really good care of your bees, make sure they're really well taken care of and everything, and you hopefully don't need to worry about Nosema. If you have a significant Nosema outbreak, yes, there's drugs out there, but it's obviously not an antibiotic drug or anything. So.
Yeah, overall,
I think there's one question. I can't for some reason I can't find the camera view, make eye contact with you guys, but I'm somehow in the chat room. One question was like, where do you get the probiotics? If you just Google a honeybee and probiotics, I'm using a product from a company called Strong Microbials. And I've been, it's like I'm not getting paid by them or anything, so I like that. And like I said, recently there were 2 papers published that says that it doesn't do much, but I think it does. Just like as we think that probiotics really help to outcompete other bad, evil pathogens in mammals, I think it does a trick. So I think it's well worth an investment, probiotics. And habit of mine now is like after each inspections, I throw a little bit of probiotics over the brood nest.
Yeah, overall, there's lots of compliments for your presentation. People really enjoyed it.
Oh, thank you.
One other question was, what material was the PCR run on to determine the virus infection, and which lab did you send it to?
Yeah, so basically, as you saw in the little video, I collected those larvae in total and put them in ethanol. I think it was 70% ethanol, and then I gave it to our infectious disease lab. We have, luckily at UGA, we have a pathologist, and that pathologist is accessible to anyone. It's not just like in-house. They do, it's called SEEPS. It's like the Sioux and Exotic Pathology Service. So anybody with an exotic animal can actually send their samples into the UGA SEEPS Pathology Service. And Dr. McHale is doing an amazing work, and so I personally bring it to her because it's just literally down the road from my work, and give her a little oral kind of summary of what's going on. But if you would have a case like this, you can pop it in alcohol, send it to that SEEP service, and they provide excellent service.
Oh, that's great to know. Another question would be, do you have an idea what the impact on the economy is and for the agricultural field for the AFB infections?
Oh, great. Yeah, that's a great question. To be honest, I don't know. I don't know, especially one specific disease. And to be honest, I think this is a huge topic, because there is probably a certain how to say, like, dark rate regarding infections, because we are not doing the work. We're just looking at those things. Like I said, it's like, oh, and as you saw from my pictures from those frames, at most in the beginning, when I look at those things, I was like, yeah, kind of like, it looks like European foul brood. Obviously American foul brood is a little bit easier to kind of like have a strong index of suspicion because of that ropiness and stuff. But what the damage is to the economy, I have absolutely no idea.
Okay, I think those were all the questions that we had. Again, that was a great presentation, Jörg. Thank you very much. Thank you for joining us.
All right.
And then hopefully see you all next time.
Bye, everyone. Thank you so much.
Nice to see you all. Take care. Have a good day.
Goodbye.
Bye-bye.